So now what we need to do is find a way to connect the combat text system to each of the health components as they spawn in. So groups don't exactly make sense because groups don't notify you when a new object is added or removed from the list of groups. But we need to connect to a signal that will occur on each of these health components when their health has changed. Now, grabbing each health component when they enter the scene is also probably a little bit tricky. So I think another solution would be to have an intermediary resource object. We could call it a signal bus, or maybe something like a combat state that has a signal. And then whenever we emit the health changed signal on the individual health components, we can also emit, say, combat state.healthChange.emit. And then we can just connect to it inside of the gameplay combat text systems. So let's go up to the root of our project. We could put this under data because it's kind of like going in the transmission of data, but I might prefer something like a new folder, and we'll call it state. So if I right click on state and create a new script, we'll call this combat state, and this will inherit from resource. Okay, we'll create that in there. So the combat state, we'll make that the class name combat state. And this will have a export var health changed, which is going to take a health component, a new value, a new health value, and the amount changed. Okay, and this should actually be a signal, not an export var. So signal health changed. Of course, we'll probably add extra stuff to this later on, but for now, that might be all we need. So if I right click on state and create a new resource and we look for combat state, let's save that under state, combat underscore state. Okay, so we have the one combat state there now. So we can go over to our health script and get a reference to it. So at export var combat state of type combat state, and we do combat state dot health changed dot emit self current health and amount changed. All right. Now when we're setting up the health component, we want to go to the inspector and make sure we quick load that combat state. Quick load the combat state. Yep. Now there's also the option of perhaps making it a global object so that you don't have to assign it in the inspector. I think that's mostly a matter of preference. Here, if you do leave it as an export, you do have the option of separating the resource into multiple resources of the same type that may exist in your project. But I think either will work okay for our situation. So now in the combat text system, we just need at export var combat state, type combat state. Okay, and when that's assigned, we want to connect to the health changed signal. So if is instance valid combat state, well, at this point, we'd be disconnecting from it. So combat state dot health changed dot disconnect underscore on health changed. And then we set the combat state to the value that we pass in during the setter function, of course. Then just take this down here and do connect instead of disconnect. So basically, if there's an old combat state, when we set the value here, we disconnect from the signal, we set the combat state, and we connect to the new combat state signal. So now we need the signal callback. So function underscore on health changed, which takes a health component. So p health, the new amount. So p new int, and the amount changed, p amount of type int. Okay, now from our combat text system, we can basically do whatever we want with it. The health component is a node 2D. If you haven't already set it to a node 2D, you can do that so that this has a location in the game world. That makes it helpful when we want to set text on it. So we need to basically have an instance of the text that we're going to instantiate, and then we put it right on top of the health area, perhaps by some offset, and show the amount changed, and perhaps red or green text, depending on if it was damage or if it was healing. So let's put a reference to a packed scene that we can instantiate. Export var text template, we can call it, which will be a packed scene. And on health changed for right now, we'll pass. So we need to create a new packed scene for text. Let's create a new scene This will be user interface, and we want it to be, I guess, just a label. So let's right click, change type to label. And we'll call this health changed label. Sure. Let's put in some default text like 100. Okay, so we can see that's like really tiny up there in the top left. So we might want to change the font size. You do that on label settings. So new label settings, font, let's say 36. Okay. If you want, you can change the font to something else as well in your project. You can also use themes for that. I won't really get into that in this tutorial, but there's template. Let's quick load that from the project. We want our health changed label.tscn. Our combat state, we quick load that to be our combat state.tres. Okay, so we have the reference there. We connect to the signal, and now we need to spawn the text template. So let's get the spawn position, which is going to be the phealth.global position. And we also need to instantiate the text instance. So text instance equals text template dot instantiate. We will add that as a child to, let's say, the UI. So we need to reference the UI parent. So let's say export var UI parent, and this will be some control. So inside of our gameplay scene, we can create the UI. I'll add a child node. Let's just say control. I'll rename this UI. And then I'll assign the UI parent as something we can put the text under as a child. Okay, so whenever we instantiate, we do UI parent dot add child, and that's going to be the text instance. Then we set the position to be the health values position. So text instance dot global position equals p health dot global position. We can also mention that this is supposed to be a label as the root. So that'll make it easier to do stuff like text instance dot global position, because now the code understands that it's a label, so it has all of its properties. Then we want to like move the text up. We also want to set its color depending on the value. So we'll set the text instance dot text to be equal to a string of the p amount. Okay. Now for our label, we might want to do stuff like read the text and then see if it's positive or negative. If it's negative, then we make the text red. Otherwise, we make the text green. So let's add a script here. We can put it in UI health changed label. That seems good. I'll create, give it the class name, health changed label, and we'll have some settings over here. So at export var. So let's say that we have a class for determining the colors we set inside of the game. So we could say at export var, maybe game colors or something like that. And this will be a game colors resource. So for that and data, we'll create that. I'll right click, create new script, game colors.gd extends resource. So in here we'll have export var positive, positive health, which is a color. We'll default this to color.green, lawn green, why not? Because we have this bit, setting it to a default value, this is actually unnecessary. And then we can do export var negative health, which will be color.red, and just pick a random red. Firebrick, sure, that sounds cool. And let's give it a class name of game colors. Okay, now we need to create an instance of the resource. Right click on data, create new, and then we'll do game colors.gd, save it as game colors, save it in there. Now we need to reference these values in our health changed label. So over here, we just save that again, and we get the game colors resource. We assign it in the inspector. It should pop up here. If it doesn't, we have to reload. So project reload. Okay, and there we go. We have the reference to the game colors. So we need to quick load this from gamecolors.tres, and now we have access to these colors. So the reason I did all that is just to make it consistent. So if we have anything else in the game that needs to reference colors, like maybe you have a text tooltip for an item and it shows how much healing it does or how much damage it does, then you can use these same colors there. as well as in the health changed label. So just combining everything into one resource and then sharing it across the project. So we have the game colors. When we set the health changed label text, let's see if there's a signal for that. Control, not seeing it, to be an integer. So text is going to equal the string of the p health change. And then basically, if this is positive, we'll show the positive health. If this is negative, we'll show the negative health. If it's 0, that's a good question. Maybe we just show negative, or maybe positive. Okay, so if p health change is less than 0, then let's say the color, let's see, how do we set the text color? Text.color. So we could set the self-modulate property on it, which changes the color of just this label component, but not children components. So let's say self-modulate equals game colors dot negative health. Otherwise, self-modulate equals game colors dot positive health. And then now in the system, we're going to look for a health changed label. So in gameplay, combat text system, we expect it to be a health changed label. So if not, or let's say if not is instance valid, text instance, then we're going to push an error, instanced a scene that is not a health changed label. And then we'll return here because we can't do anything with that. Oh, we should also remove it from the scene though. So text instance.free. Okay, just to make sure we clean that up from the scene. Okay, so assuming it is a health changed label then, we are going to, instead of just setting the text directly, we'll do text instance dot set health text, and we pass in the amount changed. Okay, and that's what we need to do there. So let's see if we hit play, if we can actually get them to instance at all. Let's see, node 2D, so it can't be assigned to node, right. So for the health component, we do need to make sure that we change them into a 2D node. So in player, I'm going to right click, change type, node 2D. And in invader, I'm going to right click, change type to node 2D. So let's hit play, and I'll try shooting a enemy. And let's see, invalid access to get current health on type null instance. I guess because these changed their base type, I need to reassign them now. So that's a little annoying, but let's go into invader and let's see. And then object blackboard setter will assign the health. And then in player, object blackboard setter assign the health. Hit play one more time. We'll try shooting. And it's still having an issue. So the hurt box needs that reference to the health. So the hurt box in player is down here at the bottom, assign the health. And then invader, I'm going to get the hurt box, assign the health component, hit play. And let's shoot. Okay, so the set shader action is not finding the sprite dot material. So if we do actor dot sprite, we can see that's not there. And that's for the invader. I must have just forgot to assign it. So in invader, we assign the sprite, which is the sprite 2D, the character sprite 2D, hit play. Okay, let's try shooting again. And our text does not at the moment. Okay. If we check world, oh, that's why. Because we're still loading the game world. We're not loading the gameplay scene. So we need to change our project settings to run, not the world scene, but the gameplay scene, so that all of our systems, like the combat text system, load, as well as the UI. So if we hit play, we can see that the text is way bigger than we would have thought. So we'll need to shrink the font size at the very least. Also, when the characters load, the health changed signal triggers. So we need to be careful about that and make sure that doesn't actually occur on the first load.